Hello everyone and welcome to today's session. We are going to cover two very important and frequently asked interview questions, one from SQL and one from statistics. The first question is about the conditions that define a primary key in SQL, and the second is about the types of statistics used in real world data analysis and model building. Both of these topics are absolutely essential for anyone preparing for a data analyst, data scientist or SQL developer interview. So let's dive right in. Let's begin with the first question. What are the conditions for a primary key in SQL? A primary key is one of the most fundamental concepts in relational database design, and understanding its rules precisely is very important. The first and most critical condition is that a primary key must be unique. This means that no two rows in the table can have the same value in the primary key column. Every single record must be distinguishable from every other record through its primary key value. If duplicates were allowed, the entire purpose of the primary key would be defeated because you would no longer be able to identify a specific row with certainty. The second condition is that a primary key cannot contain null values. Null in SQL represents the absence of value. It means unknown or not provided. Since the primary key is responsible for uniquely identifying every row in the table, it is absolutely mandatory that every row has a valid, non-null value in that column. A row with a null primary key would be unidentifiable, which is completely unacceptable in a well-designed database. The third condition is that each table can have only one primary key. While a table can have many columns and many types of constraints, there can be only a single primary key defined per table. This enforces a clear and unambiguous method of identifying records. The fourth condition introduces an important concept: composite keys. A primary key does not have to be a single column, it can be a combination of two or more columns. As long as the combination of those columns together is unique across all rows. For example, in an order details table, neither the order ID nor the product ID alone might be unique, but the combination of both together can uniquely identify each row. This combined primary key is called a composite primary key. Finally, the overarching purpose of all these conditions is to ensure data integrity. The primary key guarantees that every record is in the table is uniquely identifiable at all times, which is the foundation of reliable and consistent database design. The key takeaway is simple. A primary key is the unique identifier of every record in a type table. It must always be unique. It can never be null, and each table can have only one. Excellent. Now let's move to our second question, which is a very common behavioral and technical question asked in data science and analytics interviews. What type of statistics did you use in your previous organization to analyze data and build models? This question tests both your theoretical knowledge of statistics and your ability to apply it in real world scenarios. Let's look at the three major categories of statistics that are used in professional data work. Statistics used in data analysis. Statistics in data analysis and model building can be broadly categorized into three levels: descriptive statistics, inferential statistics, and advanced statistical techniques. Each plays a distinct and important role in the data science workflow. The first category is descriptive statistics. As the name suggests, descriptive statistics is all about describing and summarizing your data so that you can understand its basic structure before doing any complex analysis. The most commonly used descriptive metrics are the mean, median, and mode, which together give you a sense of the central tendency or the typical value in your dataset. The standard deviation and variance tell you how spread out or dispersed the data is around the mean. A low standard deviation means the values are clustered closely together, while a high standard deviation means the data is widely spread. Understanding data distribution. Whether the data is normally distributed, skewed, or follows some other pattern is also a critical first step before applying any machine learning model. Descriptive statistic essentially gives you the big picture summary of your data. The second category is inferential statistics. While descriptive statistics tells you what your data looks like, inferential statistics allows you to draw conclusions and make predictions that go beyond the data you have. By using a sample to make inferences about a larger population, hypothesis testing is one of the most powerful tools here to allows you to test whether a particular assumption or claim about your data is statistically valid or not. Confidence intervals give you a range within which the true population parameter is likely to fall with a specified level of certainty. For example, a 95% confidence interval. The p-value is a key output of hypothesis testing. If the p-value is below a significance threshold, typically 0.05, you reject the null hypothesis and conclude that your result is statistically significant. Sample analysis involves working with a representative subset of your data and drawing meaningful conclusions that apply to the whole population. The third category is advanced statistical techniques, which are used when building predictive models and performing deeper analytical tasks. A regression analysis is used to understand and quantify the relationship between a dependent variable and one or more independent variables. It is one of the most widely used techniques in machine learning and forecasting. Probability distributions such as the normal, binomial, and Poisson distributions help in modeling the likelihood of different outcomes and are foundational to many machine learning algorithms. A/B testing is a technique commonly used in product analytics and marketing, where two versions of something are compared to determine which one performs better based on statistical evidence. Correlation analysis measures the strength and direction of the relationship between two variables, helping analysts understand whether variables move together and how strongly they are related. The key takeaway from this slide is that statistics is not just a theoretical subject, it is a practical, everyday tool that data professionals use to understand their data, validate their findings, and make better, more confident, data driven decisions. Thank you.